In the vast darkness of our universe, every star is supposed to have a limit, a breaking point where gravity and heat reach a final, deadly stalemate. But deep in the cosmos, we've discovered celestial outlaws that are shattering the laws of physics. These behemoths are bypassing the Eddington limit, cannibalizing their neighbors to grow into monsters that should not exist. What happens when a star refuses to die? What if a star becomes a hunter? The terrifying fluid dynamics of runaway accretion. Massive stars, bypassing every standard process of gradual change and development over time, by literally devouring the space around them. What appears to be more than just growth, a cosmic heist that is forcing us to rethink everything we know about stellar survival. Imagine a star so massive it defies the very equilibrium of the universe. While most stars reach a stable size and settle into quiet middle age, these outliers are caught in a cycle of infinite growth. Today, we dive into the hidden dynamics of stars that never actually stop growing. For a long time, it was believed that stars lived by a simple, unbreakable rule: hydrostatic equilibrium. Inward gravitational pressure, perfectly balanced by outward radiation pressure from nuclear fusion in the core. This balance has a hard ceiling, known as the Eddington limit. At a certain mass, roughly a few hundred times that of our Sun, the star's own light becomes so intense that it should blow its outer layers away into space, preventing further growth. However, the current James Webb Deep Field surveys have revealed stellar anomalies that shouldn't exist. Stars far more massive than theory allows, glowing with impossible brilliance in the early universe. These monsters are born in the chaotic hearts of dense star clusters, where gravity forces stars into uncomfortably close binary orbits. Here, the process begins with Roche lobe overflow. The more massive primary star stretches and distorts its smaller neighbor, siphoning plasma directly from its atmosphere. But in these extreme cases, something far more violent happens. We can refer to this as runaway accretion. Matter pours in faster than the star can radiate the energy away. The inflow becomes a deluge, overwhelming the star's natural defenses. So how do they survive this onslaught? High-velocity fluid dynamics and strangely porous atmospheres allow fresh matter to slip through gaps in the radiation pressure. Intense magnetic fields act as brakes, shedding excess angular momentum so the growing giant doesn't spin itself apart. These behemoths hide their growth behind thick cocoons of dust and gas. What we see from Earth is only the calm exterior. Inside, a violent, unseen feeding frenzy rages on. As they gorge themselves, their internal chemistry shifts dramatically. Increased pressure fuses heavier elements at rates far beyond standard models. These stars become blue stragglers. These blue stragglers, appearing deceptively young, hot, and vibrant, even as they carry the mass and hidden age of true giants. They no longer follow the normal path on the Hertzsprung-Russell diagram. They have become supermassive hybrids, a new class of stellar outlaw. Rather than ending in spectacular supernovae, many appear destined to collapse directly into intermediate mass black holes. These growing giants may be the missing link that explains the mysterious origins of the supermassive black holes, already dominating the centers of the earliest galaxies. The universe, it seems, is far more flexible than we believed just 2 years ago. These rule-breaking stars remind us that the cosmos still holds forbidden physics. Mysteries that challenge our deepest assumptions about how stars live and how they die. And somewhere out there, in the darkness, new monsters continue to feed.